Uh, all right, my name is Dan Sullivan. I'm a software solution architect, mostly in the Americas. So um, I spent a bunch of time in my career in software development, and then a few years ago I joined TLF. A year or so before the acquisition. I spent most of my time working with service provider customers. And today's talk is reconciling out-of-band service changes. So essentially, when someone changes the service intent out of band, how could you possibly handle that? It's always been my dream to be on a big stage, but I thought I would be telling jokes instead of this. But maybe if this goes poorly and people are laughing, same effect. So we'll see how it goes. Oh, I will. It's always reassuring to have the few members of the red team sitting in the front row right there while you're giving your presentation, ready to jump on you if you utter some falsehood. So we're like quick agenda, not terribly interesting. So from a problem statement perspective, so a lot of NSO customers are pushing services using NSO, but a lot of them are struggling about what to do with out-of-band changes. So we even have some customers who are pushing services, and then when their service intent gets modified by out-of-band, they actually don't know what to do, and they don't use NSO to push changes after the initial service creation, which I think is a bad idea. So the question is, how do we handle these out-of-band changes, that occur and actually update the NSO service intent? So in general, I mean, you could just say, we used to tell people, well, if someone modifies the config out-of-band, just tell them to modify the service, but that just doesn't work. People don't, or they forget. So I thought I'd take a look into how we might do that. Most importantly, a lot of people are moving towards LSA, so anything we do to handle out-of-band changes has to work in an LSA environment as well. From a change perspective, a lot of times people are making the same set of changes over and over again, adding a VLAN, changing bandwidth. And again, they should be updated in the service config, and they're not. So maybe we can't handle all out-of-band changes, but even if we handled a few of the most common ones, it would probably improve the experience and usage of NSO in the network. I've seen some solutions to tackle this problem, and some of them were really code intensive, lots of Java code. And then because those solutions are device config dependent, when the devices change or something like that, there's a lot of work to maintain that sort of thing. If you change the service model again, you're kind of back to square one. Very tough to maintain. So the idea is we sort of need a solution that we can apply to multiple services, which isn't so code intensive, right? And in general, the NSO service templates or config templates get you pretty close. So I would argue that you can do a lot of what you need to do just with templates themselves. So essentially, the idea is that reconciling out-of-band changes is sort of the reverse of a service activation, right? In a service activation in your template, you're reading from your service model and you're making changes from the device model. So if you want to reconcile out-of-band changes, it's essentially just going the other way, looking at the device model and then updating your service config. So why don't we just do that? So I have a quick demo. I didn't realize I was going to have so much time. Thomas plowed through his slides so quick that it left me with more time. I feel no need to use up all of his time, though I'll stick to my time. So I have a short demo using NSO. I put NCS in there, but it's NSO 4611. And I have one service node and two device nodes and a few NetSim devices and an iOS XR. There are iOS XR based devices. And And we'll use NSO service templates, and we won't use any Java and Python to do the reconciliation. So if that's compelling, stick around. If not, now's your chance to run. All right. So to increase the believability of my demo, I have some code, and I'll show you a little bit of this first. The reconciliation itself is actually implemented in Python. So I said there was no device-specific code, and there isn't. But there is some things that you need to do, and that part is in Python, but there's nothing really service or device-specific other than maybe a few of the log messages. So I've actually done this for a couple of different services using roughly the same code with minimal change. So hopefully if you were to employ this method, you could roughly leverage the Python code and not necessarily have to reinvent that every time you did it. So how do we do this? Well, the first thing is I have a simple service that builds VRFs, and I'm doing it on Cisco devices. And I have the usual set of parameters, but down on the bottom you can see that there's a reconcile action, so out-of-band reconcile action. And this is an LSA example. So for the upper node, there's a reconcile action. And then for each of the service instances on the lower nodes, there is an additional out-of-band reconcile action. And what will happen is when we start the reconcile action on the service node, it'll basically query the service instance and figure out which other LSA nodes have the service incorporated, and then we'll invoke their reconcile actions. So that, and that will be done in parallel. So the reconcile action will happen across the device nodes in parallel. Now, the good thing about the reconcile action is you can largely view it as a CDB manipulation, right? If you are reconciling out-of-band changes, the idea is that you already have the changes in the CDB and you know your service intent has changed. From a timing perspective, we would expect this to be fairly quick as compared to your normal service activation, in which when you're pushing a service out, most of the time isn't really spent in the CDB, but rather talking to devices. So in this case, it should be relatively quick. So that's about all the interesting code I have at the moment. So now I'll try to run the demo and see how it goes. So I'm on the service node here, and because I thought Thomas would take longer, I saved everything in an XML file so that I could just load merge. So I have this file called VRF. So if I do show, you can see there's my configuration that I'm going to push. I have a route distinguisher and some route targets, route policy, and I'm going to actually send this to 2 devices. So if I do the commit dry run here, you can see that it's going across 2 LSA nodes. So it's going to push XR0 is on the first LSA node, and XR1 is on the second NSO node. So I'll just that change if I spell it correctly. So that was great. Everything's out in the network. So now the next point is let's simulate what happens if someone changes the service intent. So if I just go to a device node, I can start to cause some problems. So in this case, what if I added another route target? So I'll do that. And I'll play with the maximum threshold. So in this case, we actually are going to push another route target out to the device, and we're going to set the prefix limit and the threshold. So if I just push that out there. So now I've effectively sort of the same thing as someone modifying a device out of band and me syncing the changes to the lower node. So now if I went up here and tried to do request services verf, first I'll do a check sync, and of course it tells me that NSO is out of sync, which is what we would expect. So we can sync from the nodes. So now if I do the same thing, I see that my service is out of sync. So if I were to simply redeploy my service here, you can see that basically what it's telling me is that, hey, there's this route target should be removed, and the prefix limit and the threshold value should be deleted. So you would imagine and actually the reason I came up with this, because I actually had a customer who is in production today with NSO, and they have sort of an issue with route targets being added out of band, and they needed to be able to handle that. So I actually have someone sort of running this in production, something similar to this. So now instead of, if I redeploy, I would lose those changes. So instead I'm going to reconcile. So what I can do is I want to update my service config to match these changes. And if you look, I have a new action here, out of band reconcile. So again, this is on the service node, but the real interesting work will take place on the device nodes. And God willing, this will work. No. Okay, so it says that we committed, that it made a commit, so it looked like it was successful. So if we type show services verf, we can see now that when I set the prefix limit, before it wasn't part of the config. And the same thing here for this route target that was not part of the service config and now is part of the service config. So I've effectively been able to incorporate the service intent back into my service model. So now if I wanted to make a change to my service model, I would make my change and I wouldn't lose those out-of-band changes if I needed them. But there could also be a point at which, hey, I have some set of changes that I don't want to reconcile, and so I have an example of that as well, so I'll try that. So what I did is I purposely didn't allow you to change the verf description. You can reconcile the other changes, but you cannot change the description, so I'll just commit that. Same thing over here. If we were to do a check sync, it's out again, so sync from. We do a dry run on redeploy. Oh, what happened? That worked and it wasn't supposed to. Let's see. Oh, my verf was, I didn't modify correctly. Anyways, yeah, it was XR0. That's what I did, right? I was really hoping this was going to go better. Try this again. So now you can see it's going to replace my description. But of course, if I do the normal thing that I just did, I could say, let's reconcile this. In this case, the reconcile fails because we don't have support. We specifically decided that this change wasn't something that we wanted to take back in. And so we can look a little bit, I can show you, let's see. And sort of here's the template that I applied to do the reconcile. I actually used the new template support in 4.6 for this. But if you look at it, you see that on line 18 is where I set the context to the device and the specific verf. And then I basically read back the config elements that I want to reconcile. So you can do this, and this doesn't take long. It's essentially the exact opposite of the other template. I would argue and say in the future it would probably be possible to actually render some of this automatically. I'm sure my good friends in the front row can figure out a much more elegant way to do it. But that was the idea. I've done this a few times, and it seems to hold up. So I'll make the code available at some point. I'm not sure how we'll distribute it, but if you're interested, you can definitely take a look. Anyone have any questions?
You're saying that this is your reconciliation template, basically. Is that?
Yeah. Right. Yeah, but it just kind of goes backwards, right? On the device node, you go from the device to the service. Then you do a sync from, and on the upper node, it goes from the config from the lower devices into to the top service instance.
Would it be possible to augment your action to include for example, dry run Boolean input parameter? So I know you can do that part, but then if you had that, could you output dry run back out to the console to add sort of a dry run version of this? So you can see what's changing in the services branch before you actually commit it?
Yes. Pure laziness is the only reason it's not in there. Actually, when Jan Lindblad asked me to make a presentation, I was pretty cocky about it, thinking I had oodles of time, and I did at the time he asked me, but by the time I got to work on this, but yes, very good idea.
But so how would that be implemented? Would that be within your Python code after you apply template? Would you just do a commit dry run within that transaction and then it automatically outputs to the console?
It does that anyways. Actually, the Python code is actually doing that very same thing. Because that's how it determines if the upgrade, if the out-of-band reconcile is successful. The way that you do it is you apply the template and you basically then do a commit dry run. If nothing comes out, if it's not trying to send anything to the device, it worked. If it still wants to make a change to the device, the reconcile failed. So that's essentially what it's doing.
Okay. And secondarily, I hold you in high esteem, Dan, but someone else from Cisco that I also trust just told me that I should never do a sync from. So isn't that a prerequisite for using this method?
No, what he said, so excellent point. But at some point, if your service is out of sync, you need to reconcile it with, so this would work just as nicely with partial sync as well, and perhaps even a more targeted sync from for the specific area of the config. Yep.
I think the key point is that you should do the analysis and know. You shouldn't just blindly do sync from. You should understand, and I hear you know that the route targets and the max threshold, those are values that are valid to reconcile. We can go there.
Yeah,
That's
so
okay.
the specific reason, if you notice, I never actually did any sync froms in here, and that was the reason why, because I didn't want to say, but you could use partial sync just as well. But if for the customers that are, I would argue that you could do the reconciliation anytime that you wanted, right? And the fact is that we had some customers who were only doing service activation, and then they wouldn't do any service modification because of this. And I would argue that I think it would be worth a partial sync or two to get your service back in sync with the network and be able to drive automation through it. All right, I guess we're set. All right, thanks for your time.